to calculate the galvanometer resistance and the figure of merit using the half deflection method. So for this, the formula given is Rs by R minus S, and then the figure of merit is a current divided by the divisions, ampere per division. So here you can see the current is voltage by resistance. So V by R is E by R plus G. That is the total resistance of the galvanometer, and then multiplied by the deflection, total deflection of the galvanometer. Okay, so using this here and here you have to write the unit. Please keep that in mind. Okay, so once the formula is written, you will draw the circuit diagram. There is no graph for this one, so no need for the model graph. And then you will write the table. Okay, so in the table, you can see here we have clubbed two tables together. Usually we will write two different tables for finding the G value, and the figure of merit is a separate table. But here we are clubbing the two tables here together. So the table goes like this. This is serial number, EMF of the cell, R ohm. So EMF is measured in voltage. So you will write the unit V volt here. This is R measured in ohm, and theta is measured in divisions. S is measured in ohm. Theta by 2 is also in division. G value is Rs by R minus S is in ohm. K value is E by R plus G into theta. And you will see that we are going to get the answer in 10 power minus 5. So here you can include 10 to the power of minus 5 ampere per division. Okay. So before entering into the experiment, I will show you how to do the how to understand the circuit diagram. Okay, so you can see the circuit diagram here is there is a primary coil, a primary circuit, and there is a secondary circuit. Okay, so you just forget about this part. Okay, so forget about this part. You will be removing the key from here. So this part is going to be removed. So in the main circuit, you can see there is a resistance, known resistance R, and there is a galvanometer resistance, capital G. So this is where you get that R plus G from. There is a total resistance in series. Okay, and then when you connect the key K2, what happens is this portion, okay, of the circuit also gets connected with the galvanometer in parallel. So this is the shunt resistance. Okay, so what we are going to do is, first when we when key K2 is open, okay, it is not connected, so we are passing the current through this resistance. You have to send the current to the galvanometer. So you will make sure that the galvanometer gets full scale deflection for the first reading. Okay, so in all the cases the EMF of the cell is going to be 2 volt. Okay, we are going to keep the EMF in 2 volt, and for 30 divisions of the galvanometer, the reading that you're going to get here is going to be 3600 ohm. So when you do the experiment, you will see for 30 divisions of the galvanometer, the reading for the resistance box will be 3600. Okay, so anything above or below that will be deflecting from the 30 division scale in the galvanometer. Okay, so once that is obtained, that reading is taken. Okay, you will not change this reading. You will connect the value, you will connect the key K2. So once you connect the key K2, you have to adjust the shunt resistance in such a way that half of the divisions, the galvanometer first was 30 divisions, so now it should get half of the divisions. What is the half of 30? Half of 30 is 15. Okay, so the value for which you will be getting half of that is going to be 110, or whatever similar reading that you will be getting in your particular galvanometer. So this reading really depends upon the galvanometer that you are choosing. So these two columns depends on the galvanometer in your particular lab. So this is just an example of how the readings will be. Okay, so this is not the actual this is a proper reading, but this is an example of how the readings will be given. Okay, and then when the first reading is done, now for the second reading, what you will do? So in the first again you will open the key K2, and then the main circuit is alone connected. So you will now make sure that you get 28 divisions in the galvanometer. For that, according to that, you have to adjust the resistance. So second time you are going to get the value 3900 or 4000, around something like that. And then when you connect the key K2 for the same value of 110, you will be getting the half scale deflection. Okay, so what does it show you? Half of the current is going through the shunt resistance, which means that this shunt resistance, whatever value you have connected here, and the galvanometer resistance are almost equal, because half of the half of the current has entered into the shunt, which means the resistance of the galvanometer and the resistance of the shunt are equal. Okay, that is why half of the current has gone, isn't it? So that is why the name comes half deflection method. Okay, and for the third reading, you have to make sure that you get 26. Okay, So when you get to 26, the reading will be 4300 for the same shunt value 110. So here you can see this is 30 becoming 15, 28 becoming 14 and 26 becoming 13. Okay, so that is the half value. Now you have to calculate this RS by R minus S. So when you calculate this RS by R minus S in a calculator, what you have to do is you will type in the calorimeter. Imagine you're typing in the calculator. So you're having 3600 into, okay, what is this shunt value? 110. And then what you'll do, you will divide, isn't it? So you will divide and then you will open a bracket, because here you have subtraction, isn't it? So because you are subtracting two values, you will open up a bracket here. So open the bracket and then 3600 minus 110. So when you do this calculation, you will get the answer. What you will not do is, if you do this without the brackets, what will happen? This value will be done first and then the 110 will be subtracted from the total value, which will be giving you a wrong answer. So when you do this way properly with the bracket, you will get the answer to be 113.2. Okay, similar calculation for the remaining two, you will be getting 113.1 and 112.8. Okay, so once it is done, you will take the mean value. So the mean value will be, once again, how to calculate the mean value? So the mean value will be 113.2 plus 113.1 plus 112.8 divided by 4. So when you do this, divided by 3, since 3 readings are there. If 4 readings are there, you will divide by 4. Okay. So, in the calculator, what you will do is, see. So in the calculator, you have 113.2 plus 113.1 plus 112.8. What mistake you will do, you will divide by 3. You will type like this, which is wrong. If you do this, only this part will be divided by 3 and then this will be just added up, which will give you wrong answer. So what you have to do, you have to bring a bracket here. So open up the bracket, write the values for the sum and then close the bracket, and then the sum is divided by 3. So once you do this, you will get the answer. Okay, so the mean value is, sorry, the mean value will be, just let me calculate. So that is 113.2 plus 113.1 plus 112.8 divided by 3. Okay, so that is going to give me 113.03. Okay, or 113.0. So this much ohm. So you have to write the unit here, 113.0 ohm. Is it clear, children? Now, to find the figure of merit, what you have to do is, once again, let me warn you how to use the calculator. So this is, the formula is E by R plus G, okay, into theta, isn't it? So what you have to do in the calculator, what is the EMF value here? EMF value is 2. Okay, so 2 divided by, then you will open two brackets. Okay, one is for R plus G. What is R plus G? So 3600 plus, what is the G value that you have calculated here? 113.2. Okay, close the bracket and then you will multiply, put one into sign and then you will multiply this value 30. Okay, so what is the theta value? Theta value is 30 and then you will close the bracket. So when you do this calculation, you will get the answer for the figure of merit. So let me do it. 2 divided by, open bracket, 2 brackets, 3600 plus 113.2, close one bracket, multiplied by 30, close the bracket. Okay, so you are actually getting 0.000017954. Okay, so what this is equal to is 1.79 into 10 to the power of minus 5. So you can see already here I have mentioned 10 to the power of minus 5. So here I will just write 1.79. Is it clear, ma? Okay, so similarly I have to do for the remaining readings. So 2 divided by, open two brackets, 3900 plus 113.1, close one bracket, multiplied by 28, close the bracket. So you will be getting here 1.78. Okay, and then third reading, 2 divided by, why we are using 2? Because everywhere we have used the same voltage value. So 2 divided by R plus G, open two brackets, that is 4300 plus 112.8, close one bracket, multiplied by 26, close another bracket. and then you will have 1.74. Okay, so you have got three values for the K. Now you will take the mean value, 1.79 plus 1.78 plus 1.74 equal to, then you will divide by 3 or you will use a bracket as I have mentioned earlier. So 1.77 into 10 to the power of minus 5 ampere per division. Okay, so this is the calculation. So ampere per division you have to mention here once again. You will write the unit. Is it clear? So once this is done, you will write the G value, that is the 113.0 ohm, and the K value is 1.77 into 10 to the power of minus 5 ampere per division. So if needed, you can also show the calculation for every G value. So the first G value, second G value, and the third G value, which is 113, 112 something. And then you can do the mean calculation. So for the mean calculation, you can write this answer. Is it clear? And then the same way here also you can do 1, 2, 3 figure of merits, and then you can take the mean value, and then the mean value can be written here. Okay, so individually separate calculation must be shown in the calculation part. Okay, once that is completed, you will write the resistance value, that is the mean value is equal to 113.0 ohm, and the figure of merit is 1.77 into 10 to the power of minus 5 ampere per division. Okay, I hope it's clear.